Welcome back to the deep dive. Today, we are opening up the hood and looking directly at the engine. We're talking about compute. And I feel like compute is one of those words that everyone uses, but if you ask three different people what it means, you get, three different answers.
You absolutely do. For the old school crowd, compute is a server. It's a box in a rack with blinking lights.
Right.
But in the cloud era, and specifically for the Azure Administrator compute, it's a spectrum. It's a massive menu of options.
And that's our mission today. We are taking a stack of research, exam prep guides, and documentation focused on the Azure Compute pillar, specifically for that AZ-104 exam, and we're going to decode it.
Yeah.
Because the goal isn't just to pass a test. The goal is to move from I know how to click a button to I know how to build a brain for my application.
Right. We want to take you from being a user of the cloud to an architect of the cloud.
Yeah.
And that means understanding the trade-offs.
The trade-offs, exactly. Why pick a massive virtual machine when a tiny container could do the job?
Or why manage an operating system at all when you could just manage your code?
Exactly. So here's the roadmap. We're going to start with the foundation. Automation. Why manual deployment is actually your enemy.
It really is.
Then we'll look at the heavy lifters, virtual machines. After that, the lightweight revolution, containers, and finally, the platform power of app services.
The perfect progression from, total control to total efficiency.
Let's jump in with segment 1, automation. Now, I have a confession. I really like the Azure portal.
Oh, I get it.
The interface is slick, the icons are colorful, it feels nice to click around, but our sources are pretty harsh on this habit.
Harsh is putting it mildly. The documentation practically begs you to stop clicking.
Look, the portal is fantastic for learning.
Okay.
If you want to see what options are available, by all means, click away. But if you are an admin responsible for a production environment, clicking is dangerous.
Dangerous how? Like, I'm going to break something. It's dangerous because it's not repeatable. Let's paint a picture. Your boss runs in and says, we need 10 identical web servers deployed for a new marketing campaign. Right now. You go into the portal, you click Create Resource, you fill out the form, you hit Deploy. Then you do it again and again.
By server number 7, I'm getting coffee. By server number 9, I'm distracted.
Exactly. And on server number 10, you forget to check the box for HTTPS only, or you pick the wrong region. Humans are just terrible at doing repetitive tasks perfectly.
But computers are great at it.
Computers are great at it.
Which brings us to infrastructure as code, or IaaC. And in Azure, the grandfather of this is ARM templates, Azure Resource Manager.
Right. And this is a key exam objective. Candidates need to be able to interpret these templates, so we need to understand what they are. An ARM template is just a JSON file.
JSON. The file format that is basically just an endless sea of curly brackets and colons.
It is not the most human-friendly format, I'll admit.
Yeah.
But the concept behind it is really powerful. It's declarative.
Okay, let's break that word down. Declarative. How is that different from me just writing a PowerShell script?
A script is imperative. You are acting like a drill sergeant. You tell Azure, step 1, make a network. Step 2, make a VM. Step 3, connect them.
Okay.
If step 2 fails, step 3 freaks out because there's nothing to connect to. You have to enter all that error logic yourself.
And declarative.
Declarative is like ordering at a restaurant. You don't tell the chef how to chop the onions. You just look at the menu and say, I want the steak medium rare. You declare the end state.
I see. So you give Azure the ARM template that says, here is what the environment should look like, and it figures out how to get there.
The Azure Resource Manager figures out the steps.
Exactly.
That makes sense. Now, looking at the structure of these templates, because the exam loves to ask about structure, what are the non-negotiables? What has to be in that file?
So there are a few optional things like parameters and variables, which you should definitely use to make your templates reusable. But strictly speaking, to be valid, you need 3 things. First, the schema. That's that URL at the top that basically tells Azure, hey, this is a deployment file, not a grocery list.
Correct. Second, the content version. This is just for you to track changes like 1.0.0.1.
Right.
And third, and most importantly, the resources. This is the meat of the sandwich. This is where you actually define the storage account, the VM, the web app.
But let's be real, writing raw JSON it's painful, it's so verbose, you miss 1 comma and the whole thing fails.
It's a nightmare to debug. A complete nightmare.
Which is why Microsoft introduced Bicep, and I love the name, ARM versus Bicep.
That's a good pun. The bicep is a smaller part of the arm.
Yeah.
And that's the point. Bicep is what we call a domain-specific language. It's
Mhm.
designed specifically for Azure deployment. It's cleaner, it has way less syntax, and it handles dependencies automatically.
But here's where it gets interesting technically. Bicep isn't actually a new engine, is it? It's not a replacement for ARM.
No, not at all. It's a transparent abstraction. When you write a Bicep file and hit deploy, Azure takes that file and transpiles it, converts it into a standard ARM JSON template in the background.
So the robot at the other end still reads JSON, but we get to write in a language that doesn't make our eyes bleed.
Exactly. It's the best of both worlds. For the exam, you really need to be comfortable looking at both. You might see a snippet of JSON or a snippet of Bicep and be asked, what does this deploy?
Okay, so that's how we build things. Now let's talk about what we're building. Segment 2, virtual machines, the heavy iron.
IA, infrastructure as a service. This is the part of the cloud that looks the most like a traditional data center.
And because it looks like a traditional data center, it comes with traditional headaches, the shared responsibility model.
This is the biggest trap for new admins. You spin up a VM in Azure and you think, great, it's in the cloud, Microsoft handles everything.
Yeah, that's wrong.
So wrong. Microsoft guarantees that the hardware has power and internet. That's it.
So if I deploy a Windows server and I don't install the security patches,
You get ransomware. That is
Yeah.
100% on you. You manage the OS, the antivirus, the backups, the data.
it's maximum control, but maximum responsibility.
That's the perfect way to put it.
Let's talk about sizing these beasts, because one size fits all definitely does not apply here. We have the alphabet soup of VM families, D, E, F, N. How do we keep them straight?
Well, there are some good mnemonics. Start with the D series. Think D for daily or general. It's a balance of CPU and memory. Good for domain controllers, average web servers.
Okay, then we have the F series.
Think F for fast. These are compute optimized. If you have a workload that is doing heavy math or processing video or handling high traffic bursts, you want that high CPU.
And the E series?
E is for enterprise or maybe extensive memory. These are memory optimized. Think large SQL databases that need to load massive tables into RAM.
Now, here is a specific detail from the source material that feels like a gotcha on the exam and in real life. Let's say I deploy a D-Series VM. A month later, my app is super popular and the server is sluggish. I need more power. I need to resize it. What happens?
You click the button to resize and you hold your breath. Because resizing a VM, what we call vertical scaling, almost always requires a reboot.
A reboot. So downtime.
Immediate downtime. The VM has to stop, move to a different physical host that has the capacity you asked for, and then start up again.
And if you do this during business hours, your phone will ring.
Oh, it will ring, definitely.
So vertical scaling is risky. We'll talk about the alternative horizontal scaling in a minute. But first, let's talk about keeping that VM running. Availability.
Yeah, this is where we need to distinguish between availability sets and availability zones. They sound similar, but they solve very different problems.
Okay, let's break it down. Availability sets.
Think inside the rack. An availability set protects you from hardware failures within a single data center. It splits your VMs across fault domains.
Which are essentially different racks with separate power and cooling.
Exactly. So if a power supply blows in rack A, your VM in rack B is fine.
But if the entire data center gets hit by a tornado,
Then both racks are gone. Your app is down. That's why availability zones are the modern gold standard.
okay.
Zones are physically separate data centers within a region. They're miles apart. Independent power, water, networking.
So zone 1 can be underwater, and zone 2 is happily processing transactions.
That's the idea. And the exam expects you to know how to configure this. You can be zonal, where you pin a VM to zone 1, or you can use services that are zone redundant, where Azure automatically replicates the data across zones for you.
Moving to security. Because having a running VM is no good if it's owned by hackers. The sources are screaming about one specific thing: public IPs.
This is the #1 rule of cloud security. Do not put a public IP address directly on a VM unless you absolutely positively have to.
But I need to manage it. I need to RDP into my Windows box or SSH into my Linux box.
You do, but you don't need a public door to do it. You use Azure Bastion.
Bastion. It sounds like a fortress.
It kind of is. Bastion is a managed PaaS service. You deploy it into a specific subnet called Azure Bastion Subnet. It sits at the edge of your network.
And then what?
You log into the Azure portal via your browser over nice, secure HTTPS, and the Bastion service tunnels you to your VM's private IP.
So port 3389 or port 22 is never exposed to the open internet.
Never. You are invisible to the port scanners. It's a massive security upgrade.
And once we are secure on the network, we need to secure the data. Encryption.
2 layers here. Azure Disk Encryption, ADE. This uses standard tools you already know, BitLocker for Windows, dmcrypt for Linux. It encrypts the OS disk and data disks inside the VM.
Okay.
But Azure also offers encryption at host. This encrypts the data on the physical server hardware before it even travels to the storage service. It's end-to-end protection.
Okay, that's VMs. They are powerful, but they are heavy. Let's lighten the load. Segment 3, containers.
The speedboats of the cloud.
To understand containers, we have to contrast them with VMs. A VM virtualizes the hardware. A container virtualizes the OS. Why does that matter?
It matters for speed and size. A VM has to boot up a full kernel. It thinks it's a real computer. That takes minutes.
Right.
A container just piggybacks on the host kernel and starts the application process. It takes seconds. It's lighter, faster, and way more portable.
So let's look at the Azure ecosystem for containers. First, we need a place to store them.
Azure Container Registry, ACR. Think of this as your private library. You build your Docker image and you push it to ACR. It's secure, it's inside your network, and it's close to your compute resources.
Okay, I have my image in the library. Now I want to run it. The simplest way is ACI.
Azure Container Instances. I love ACI for its simplicity. It's serverless containers. You don't build a cluster, you don't manage VMs. You just say, Azure, grab this image from my registry and run it.
And the billing is interesting here.
It's per second. This makes it perfect for bursting. Let's say you have a batch job that runs once a month, takes 10 minutes, and quits.
Don't pay for a VM to sit there all month.
Exactly. Just spin up an ACI, run the job, kill it, and you only pay for those 10 minutes.
But ACI is a bit isolated. If I'm building a complex microservices app, like a shopping site with a cart service, a payment service, a catalog service, managing them as individual ACIs would be a mess.
Total chaos. That's where orchestration comes in. Now, traditionally, everyone points to AKS Azure Kubernetes Service. And AKS is amazing. It's the industry standard. But
it's complex.
It is so complex. You are managing nodes, pods, networking overlays. It's a full-time job.
And this is why our sources are so excited about Azure Container Apps. It seems to sit right in the middle.
It's the Goldilocks solution. Container Apps is actually built on top of Kubernetes, so it have all the power. But Azure hides the complexity. You don't see the cluster. You don't manage the nodes.
And it has some superpowers that matter for the AZ-104, specifically around scaling.
Yes. It uses key to Kubernetes event-driven auto-scaling. This is a game changer. Well, standard scaling usually looks at CPU. Oh, the CPU is at 80%, add more containers. Kida can look at events. Oh, there are 500 messages waiting in this queue. Spin up 10 containers to process them.
And can it go the other way?
That's the best part. It can scale to 0. If the queue is empty, if no one is on your website, the container shuts down completely. You pay nothing, 0.
That is efficient.
It is. And for the exam, remember, if you need Kubernetes features like Kida or Dapper for microservices, but you don't want to manage a Kubernetes cluster, the answer is Azure Container Apps.
Okay, let's move to our final pillar, segment 4, app services. We've done IaaS with VMs, we've done containers. What is app services?
App services is pure PaaS, platform as a service. This is for when you don't care about the OS, you don't care about the container engine, you just want to host a web application or an API.
But there's still a server involved somewhere, right? We have to talk about the app service plan.
Yes. This is a critical concept. Think of the app service plan as the rental contract for the hardware. It defines the region, like West US, the OS, Linux or Windows, and the size, so how much CPU and RAM.
And the web app itself sits on top of that plan.
Right. And here's the cool part. You can put multiple apps on one plan. If you buy a nice, beefy premium plan, you can host your marketing site, your internal blog, and your HR portal all on that one plan.
They share the resources.
They do, which is great for cost saving, but risky for performance. If the marketing site gets 1 million hits, it eats all the CPU, and the HR portal goes down. They're noisy neighbors.
Now, we talk about how resizing a VM causes a reboot. How does app service handle scaling?
Much more gracefully. We have scale up, which is moving to a bigger plan. That's manual. But we have scale out, which is auto scale.
Adding more instances.
Exactly. Azure just spins up copies of your web app to handle the load. And because it's stateless web traffic, it's seamless.
But the feature that really sells PAM for me, and the sources highlight this heavily, is deployment slots.
This is the killer feature of app services. If you are running a production application, deployment slots will save your life.
Walk us through a scenario.
Okay. You have your live website, myapp.com. That's the production slot. You want to release version 2.0.
Okay.
Instead of overwriting the live site, which is terrifying, you deploy version 2.0 to a staging slot.
Which is running on the same hardware, right?
Yes. It's a live, working URL, like staging.myapp.com. You can log in, test it, show it to the boss. When everyone is happy, you click the swap button.
And what happens technically?
Azure warms up the staging slot to make sure it's responsive. Then, it instantly flips the routing rules. Traffic that was going to production now goes to staging. Traffic that was going to staging goes to production.
So users get the new version instantly with zero downtime.
Zero downtime. And here's the safety net. The old production is now sitting in the staging slot. If you realize 5 minutes later that there's a critical bug, you just swap back. Instant rollback.
That beats restoring from a backup any day.
It changes the way you think about releases. It makes them boring, which is exactly what you want.
So we have covered a massive amount of ground. We've looked at the control end of the spectrum with VMs,
where you are the master of the OS, managing security with Bastion and encryption.
We've looked at the agility of containers,
scaling to zero with container apps and leveraging the speed of ACI.
And the simplicity of app services,
using slots to deploy without fear.
So what is the takeaway here? Why does this matter for the listener, specifically the aspiring Azure admin?
The takeaway is that your value as an admin isn't knowing how to create resources. Anyone can follow a tutorial. Your value is in knowing which resource to create.
It's the decision tree.
Exactly. You face a business problem. Do they need the raw processing power and custom configuration of a VM? Do they need the portability and density of containers? Or do they just need a simple, resilient web host via app services?
It's about balancing cost, complexity, and control.
That is the job description. And understanding the nuances we talked about today, like the downtime of VM resizing versus the seamless swap of app service slots, that is what helps you make the right recommendation.
And that is what is going to help you crush the AZ-104.
Absolutely.
Here is a final thought to chew on. We talked about container apps scaling to zero. We talked about ACI billing by the second. We are seeing a massive shift away from provisioning capacity.
We used to pay for availability. We paid for a server to sit there, just in case a user showed up. Now we are moving to paying for execution. We only pay when the code actually runs.
So are we heading toward a future where infrastructure as a concept disappears? Where we never talk about RAM or cores and we only talk about logic?
That is the serverless dream. We aren't fully there yet. Legacy apps still need servers, but for new development, the server is becoming invisible.
Something to think about. Check the show notes for links to the Microsoft Learn modules on these topics. And seriously, go deploy a Bicep file. Break it. Fix it. That's how you learn.
It's just, do it in a dev environment, not production.
Solid advice. Thanks for listening to The Deep Dive. We'll see you next time.